So from the videos, any questions from the videos?
The one and part, the 2A, B were embedded questions.
They were what? Embedded questions? Oh, good, thanks. Okay, so then, so for example 1, what's the dimension of example 1? Yeah, it's a 3x3. And so then what would we also call that? A square matrix. For example 2, does this look the same as on yours? Because I feel like this is different. Okay, that's what I was thinking. I was like, I don't think that that's. Let's see if it'll. Kind of like that. And then, but the other one is 19, right? Okay, that makes more sense. I'm like, I wouldn't have done 2 exactly the same kind of question. So then what's the dimension of 2A? Yeah, okay, so it's gonna be rows by column, so yes, 1 by 2, and we would call that a row matrix. What about example 2B? 1 by 1. So it's a what? Column matrix? So what else is it?
A row.
A row matrix. What else is it? It's a square matrix. Yeah. It's all 3 of those. Be careful, that kind of looks like the absolute value of x, doesn't it? Within the context, it makes sense. Okay, then we talk about matrix operations. So what can we do with matrices? So when you're looking at example 3, notice that my statement above example 3 says if 2 matrices are equal. All right, in example 3, are my 2 matrices equal? How do you know that? There's an equal sign there. Okay, so they are equal to each other, and then that means that all of the corresponding spots have to be equal to each other. So think about this. Think about if I said, for some reason, today's classroom is not available. We are not allowed to go into D16 today. I want you to go into D15 because I don't know your names yet, which we know that that's a lie. Since I don't know your names yet, I need you to sit in the corresponding seat that you always sit in so that I'll know who you are, right? And so you would go into that, and Becca would be in the back for me, the right-hand side of the room for you, the left-hand side of the room, and you would be in the back middle seat, et cetera, et cetera, et cetera. So it's the same concept here. Row 1, column 1 has to equal row 1, column 1. Okay, so these corresponding seats, corresponding positions have to be equal to each other. All right, so then if it says find the value of each variable, well, let's just go to row 1, column 1, and let's write something down. So what would we write down for row 1, column 1?
3 plus x.
Yeah, 3 plus x equals 9, and x equals 6. Now, when you go to row 1, column 2, are you going to write anything down for that? Well, okay, so it is a true statement that 4 is equal to 4, but what were the directions of the variable? 4 equals 4 has no variable, so I don't need to write it down. It doesn't tell me anything. What about row 1, column 3? T equals 6, that was a hard one to solve. How about let's go down to row 2. All right, so for column 1, what are we going to write down? And I'll just write 5 equals z plus 3, but what you have is totally good. So therefore, z is 2. Okay. What about row 2, column 2? Okay. What will I do in this case? So I've got 8 equals 2w. So therefore, w is 4. Okay. What about the third column there? Sorry, third column on the second row. Okay, so y is 8. You already told me P equals -4. Keep going. The next one's easy. Q equals 3. And then the last one, 2R equals R. What should I do with that? What am I trying to isolate? Uh-huh. Uh-huh. How? So when you say bring it to the other side, what operation are you using? Okay, so let's subtract R on both sides. Don't divide by R on both sides. You never want to divide by a variable on both sides to be able to cancel. If you divided by R on both sides, what would you end up with? 2 equals 1. Now, when was the last time 2 equaled 1? Oh yeah, never. Okay, so you don't want to divide by variables on both sides. That causes issues. All right, so things that we can do, again, we can add and subtract matrices. We can multiply by a scalar, which just simply means we're multiplying by a plain old number. And we have to follow the order of ops, okay? So that isn't any different. So when I look at example number 4 then, what will I do first? Yeah, distribute the 3 and the 4. Okay, so let's come up with a new matrix for the first piece. So Sierra, first row. Okay, Abigail, second row. All right, Devin, third row.
3, 0, -9.
Good. I'm gonna keep the minus sign there. You don't have to, but it makes it a little easier in my personal opinion. So I'm not distributing a -4, I'm only distributing the 4. Okay, so just leave the negative there and we can subtract later. All right, so distribute that 4 then. Mary Alice, first row. -4, 0, 0. Becca, second row. And then we got 8, 0, 4 for the last row. Okay, so distribution was first. What's next? Subtract. Okay. So we've got here. Again, this is just going to be row 1, column 1 minus row 1, column 1. So first row, Mary Alice. 709. Okay, second row, Abigail.
0, 7, and
Uh-huh. And then Sierra, the last row.
5, 0, -13.
Yeah. Yep. Okay, so for the record, you could have done this in the calculator, but there's 2 things. First of all, some of the instructions on your test are actually going to say analytically or show your work, and so you'll have to show your work on this. The second thing is sometimes I feel like on these, it takes longer to enter the matrices into the calculator than it does to do the actual math. Okay, so in my opinion, I would rather just do the math on these instead of entering it into the calculator, because that is a bit of a long and drawn out process. All right, so the next thing that we can do is we can multiply 2 matrices, but there's rules that go along with this. All right, so we have to make sure that we're following these rules to be able to multiply them. All right, so you watched the video. I'm not just going to re-explain it. Can you explain it to me? What makes me allowed to multiply 2 matrices together? What do I have to do first?
You have to look at the dimensions.
Yeah, I need to look at the dimensions, the order of each of my matrices, and what has to be true about my dimensions.
Things like the second number and the second number of the first one and the first one and the second one, they have to match up.
Yes, exactly. The two inner numbers have to match up. What about the two outer numbers? Are there any restrictions on those? No, and what do I find out about the outer numbers when I finish? They don't end up being the same necessarily. Yeah, they're going to be the dimension of my new matrix after I multiply. So the inner numbers must match. The outer numbers are going to be the dimension of my new answer. All right, so when we look at number 5 here, I don't even know what the matrices are. So all I'm doing for number 5 is just figuring out, is it even possible? Okay, can we multiply these together? So A order is a 7 by 3. B order is a 2 by 7. So possible or not possible? Not possible. So we would say that this one is not defined. All right, B times A is going to be a 2 by 7 times a 7 by 3. Possible or not possible? Okay, it will work, and the directions say to find the dimensions of B times A. So what are the dimensions of B times A? It's going to be a 2 by 3 matrix. Because my outer numbers there are 2 by 3. Okay, so let's pull our calculators out in a moment. I mean, you can pull them out now, but don't start pushing any buttons yet. I want to, first of all, for number 6, I want to know if it's even possible to multiply. Folks, don't waste your time multiplying if it's not going to be possible. Okay, so let's figure out, first of all, whether or not it's possible. So we're going to do A times B. What's the order of A? It's a 2 by 3. And what's the order of B? 3 by 2. So is it possible? Yes. And what will be the dimension of my answer? It's going to be a 2 by 2. Okay, and so now, it's coming again. Sorry. Let's go ahead and figure out whether or not B times A is possible. What's the order of B? Again, it's a 3 by 2. And the order of A? So what's the order? Is it possible? And the order of the answer? 3 by 3. All right, so let's go to the calculator. Becca, do you have your calculator today? Or do you need mine? You need mine? Bad news. I don't have my school bag. All I have is my bag that goes back and forth to home. And I don't have a calculator in here. I'm stuck. Sorry. Can't help you. All right, so go ahead. I would strongly recommend putting matrix A in for A and putting matrix B in for B. So go ahead and type in what matrix A is. I never even made it to my office this morning. Tell me when you have those entered in. Bless you. I feel your pain. All right, got them in? Okay, so now all you have to do, go ahead back to your home screen. All you have to do now is just type in your matrix A times your matrix B. So in other words, go to your matrix menu, use the name column now, not the edit column, but the name column. Push enter on matrix A, it bumps you back to the home screen. And then go back to the matrix menu, arrow down to matrix B, push enter on B, it'll bump you back to your home screen, and now it says matrix A, matrix B, and we know that there's no operation in there, automatically means multiplication. All right, so, and then you can push enter. So I don't have my class notes, so you're gonna have to help me. I know it's a 2 by 2. What's the first row? -2, 0. Abigail, did you get that? Okay, all right. Devin, did you get that?
Yeah.
Okay, and then what's the second row? -2, -5. Do you guys agree? No. Wait, this is matrix A. So that one was good. Let's look at matrix B. You really. Go, get out of there. Let's go back to the matrix mender. Let's go to the edit column. So you've got 2, -2, 5, -1, 0, pause 1. Has to be a little negative. That's all it was. And now you should be able to do second enter. Just do second enter. And yeah. One little negative throws everything off. Kind of crazy how that works. Now, the nice thing is entering in B times A is way easier because you've already got the 2 matrices right there in your calculator. So just go back to your home screen, do matrix B times matrix A. I know this is going to be a 3 by 3. Yes?
Sorry.
That's okay. Did you have a question, Devin?
No, my mom was yelling at me.
Oh. All right. So Abigail, did you get the 3 by 3? Oh, it's okay. That's what they were all doing while I was looking over your shoulder. Got it? Okay, so what's the first row that you got, Abigail? -6, is that what you guys all got? Okay. Devin, what's the second row?
-9 to -11.
Agreed? Okay, and then anybody give me the third row. I won't ask Becca though. You said -2, right? Not -10. Okay. All right, yeah, so that's not that bad. I don't teach you how to multiply by hand. I could, but by this point in the semester, we just don't, okay? We just don't. All right.